Right. Hi everyone, welcome. This is Yudesh from Easy as Pie. And welcome to our revision of cubic functions. So what I'm going to do is I'm just going to test the functionality here. So I'm just going to say hello, just seeing in the chat. And what I'm going to say is please feel free to ask questions in the chat. Okay, and I can see there's two concurrent views here. So just working on the stream settings here. The stream health is excellent. The analytics is excellent. Okay, so what we're going to do is I'm going to start by giving you a little bit of a revision of the cubic function. Okay, and then what we're going to do is we are going to go through some very typical exam type questions. Okay, and what we're going to do is we're going to start with what do we know about the cubic function? Well, we know in terms of a cubic function, we know with a cubic function, generally it's written in the form y is equal to ax cubed. So the highest power is 3 plus bx squared plus cx plus d. Now, what we can tell in this form, so this is one form of the cubic function, is remember when we have the a value greater than 0, we have a cubic function that starts increasing, hits a turning point, decreases, hits a turning point, and increases. And because the a value is greater than 0, the derivative is always going to be a happy-faced parabola. So the derivative of a increasing cubic function is going to be a happy-faced parabola. And then lastly, the second derivative is going to be a straight line, but that straight line is going to have a positive gradient. Okay, and you can see that this is what is highlighted here. Another thing to bear in mind is that the turning points of the cubic will correspond to the x-intercepts of the first derivative. Now that makes sense because we know that the turning point, at the turning point, we know that the derivative is equal to 0. And then lastly, the point of inflection will correspond to the x-intercept of the second derivative, right? Now we know that that's going to represent the point of inflection, and that's also representative of a change in concavity, okay? And of course, this is the case for when we have a is greater than 0, and then this is going to be the case for when a is less than 0. So then we will have in this case, it's a decreasing function because it will decrease all the way to the first turning point. Then it will start to increase, and then it will start to decrease. And you can see that in this case, when it's a decreasing function, I will have a sad face parabola, and my second derivative will have a gradient which is less than 0. Now remember, this is one way to write my cubic function. Another way is something known as the root form, and you would note it as a into x minus x1 multiplied by x minus x2 into x minus x3. Okay, and that's the root form. And remember that the a value in both is the same. Okay, but in this case, you would use the root form. Generally, when you're given the roots, you would use the root form. Generally, when you're given the values of a, b, and c, and d, then you would use that form. So if you can remember this about the cubic functions, you can then work out almost any question. Okay, so that's a summary. And so what we're going to do is we're going to go to a question. In this case, right, what we're going to do is we're going to underline the key information. So you're given some function g of x is x minus 6 into x minus 3 and x plus 2. Now, if we multiply this out, we know that the highest power should be x cubed. But another thing that we would note is which form have we been given this in? Well, it looks like we've been given this in the root form. Okay, the root form, remember, is some value a into x minus x1 times x minus x2 into x minus x3. Okay, now if you look at this, we need to ask ourselves what is the a value here? And if you think about it, what is the coefficient in front of the roots? It's 1. So we know that a, in this case, is equal to 1. And because a is positive, we know that this graph is going to be going up, then turning down, and then going back up. Okay, now remember that what I'm going to make you do, or what I'm going to ask you to do, is you're going to work through this. I'm going to stream some music for you, and you're going to try to work through this as if you were writing an exam. Now, of course, in an exam, you wouldn't have music. I'm just making this sort of a jam for you. And I'm just going to stream beats, stream lo-fi. Okay, now what I would like you to do is, let's pretend you're under exam conditions. You can see that the first question tells you to find the y-intercept of g. Now, how do we find any y-intercept? We let x equal to 0. Then they say, write down the x-intercepts of g. How do we find any x-intercepts? We let y equal to 0. And then they say, determine the turning points of g. Okay, and you'll notice that the last question is sketch the graph, so we'll hold that. But you'll notice that it's 1 mark for 10.1, 2 marks for 10.2, and 6 marks for 10.3. That will give you an indication of how much time you should devote to each question. And of course, what I'm looking to do is I'm looking for you to learn how to work fast under exam conditions. So generally, in the exam, you should allocate 9 marks for question 1, question 2, and question 3. But what we're going to do is we're going to give you round about 6 minutes to work out these first 3 questions. And if you complete it, then sketch the diagram. But what we want to do is we want to see how far you can go and how fast you can go with accuracy. And then we will go through it. Okay, I'm going to turn on the stream beats. And then I'm going to turn on the timer. So just need the ad to skip. There we go. Let's go. Have a go at it, and then we will discuss. Okay, so let's go through it. I'm going to remove this. I don't think, well, let's keep it there for now. Now, remember we said with the y-intercept, let x equal to 0. So the easiest way, because this is only one mark, is I would say where I see x, I put it into 0, and I'd say y is equal to, right, 0 minus 6 is negative 6, 0 minus 3 is negative 3, and 0 plus 2 is 2. And of course, that gives me minus 6 times minus 3, which is 18, and 18 times 2 is 36. And of course, I know the y-intercept is then going to be 0 and 36. Okay, so we know that this y value is also going to correspond, okay, when we bring it into the form ax cubed plus bx squared plus cx plus d, we should be expecting the d value to be 36. Okay, and like I said, if there's any questions, please put it in the chat. Okay, let's go to number 2. So with the x-intercepts, what do? We let y equal to 0. So in this case, I can say 0 is equal to x minus 6 multiplied by x minus 3 multiplied by x plus 2. Okay, now in this case, this becomes very easy because then I get x is equal to 6, or x is equal to 3, or x is equal to negative 2. These gives me all of the roots, or the x-intercepts, right? Now remember, the x-intercepts, if you had to write it in a paired form or an ordered paired form, it becomes 6 and 0, 3 and 0, and negative 2 and 0. Now, what I recommend is, as much as you can, always write in ordered paired form, okay, because it's a good habit, all right? And so I'm just going to show you or take you through, right? So you can see that the intercepts, you can see how they've written it. You can see how they've written this here, okay? And let's go back. So now we have all of this. And now what we need to do is we then need to work out the turning points of G. Now, how do I work out the turning points of G? Well, I have to get G in a form that I can find the derivative, right? Because that's the only way to work out the turning points. So what I'm going to do is I'm going to FOIL the first two, right? First two in the bracket. So I go x times x is x squared. First, outer, so minus 3x. Inner, which is minus 6x. And last, which is then 18. And then I multiply it by x plus 2. And then, of course, what I do is I then do the distributive law, but let me simplify this first. So, of course, this can then be x squared. Minus 3x minus 6x is minus 9x plus 18. And then x plus 2. And, of course, I'm going to distribute this x in, so that becomes x cubed minus 9x squared, okay, plus 18x, okay, that's the x, and then I distribute the other one, so plus 2x squared minus 18x plus 36, okay, and so what I can do here is then I can look to simplify. Okay, and if I simplify this, I have x cubed, okay, minus 9x squared plus 2, x squared is minus 7x squared, plus 18x minus 18x is 0, and plus 36. Now this is where that check comes in, right? If you look at the constant, it's 36, and if you look at the y-intercept, it's 36, so we know we're on the right track. Okay, now once we get g of x, we then need to find out g dashed of x. Now what is g dashed of x in this case? 3x squared minus 14x. And we know that the derivative of a constant is 0. And if we need to find the turning points, what we're going to do is we're going to equate that to 0. Okay, and then what we'll notice is that we can pull out a common factor of x here. So we then get x into 3x minus 14 is equal to 0. And then we get x is equal to 0 or x is equal to 14 over 3. All right. So once we then have this, what do? Well, we then need to take these values of x, and then we need to work out, or we need to plug it into the original equation. So we need to work out f at 0. And f at 0, I'm just going to go to the model because I don't have a calculator, right? But f at 0, well, we know f at 0 is 36, okay? And f at 14 over 3, well, what is it equal to? Well, it's equal to minus 400 over 27. Minus 400 over 27. So we now have the turning points, and you can see that the last or the next question is sketch the graph of G on the diagram sheet. Okay, so all we're going to do is in the exam, you would have then sketched it here. And for instance, we know that there are x-intercepts at 6, 3, and minus 2. So you would have went minus 2. Okay, put a point there. 3 and 6. We also know that the y-intercept was at 36. So you would have estimated 36 round about here. Okay, and then the turning points, we know that there's a turning point here, so we know that this graph is going to come up like this. It's going to turn and hit, and then it's going to start to go down. Okay, and then it's going to hit the next turning point, and we know that the next turning point would have been at 14 over 3, which is just over 3, and minus 400 over 27, right? So that's just over 3 there. So look something like this, and it goes up like that. Okay, of course this is a rough graph or a rough sketch, but you'll notice that we can see this is what it looks like. Okay, so we've got the shape, we've got the x-intercepts, we've got the y-intercept and the turning points, and that's where your marks would have come from. Okay, so that's how we would have done this one here. And then the last question is probably the most interesting question. And for that, I'm going to take you through it. Now, in the last question, they then say, for which values of x is g of x multiplied by its first derivative less than 0? All right, so what I'm going to do is I'm going to create a little bit of space here. Let's remove this because we don't need it anymore. And then let's write this down. So they want where g of x multiplied by g dashed of x, where is it less than 0? Now, whenever I am doing a multiplication, if I want a negative value, the combination I would need is a positive value for g of x and a negative value, because remember that will give me less than 0. Or I would need a negative multiplied by a positive, because those are the only two combinations that give me less than 0. Now, in this case, what I'm going to do is I'm going to have to use my graph. Okay, well, let's use this graph because it's a nice sort of big one. Okay, so I'm just going to move this down here and create a little bit of space. Let's just remove all of this. Now, for this, what we will need to do is we will also need to potentially draw our first derivative. Okay, so I'm going to make this nice and big. Now, remember the first derivative, right? If I'm going to draw it in green, The turning points correspond to the x-intercepts of my first derivative. So I'm going to draw a rough first derivative, right? So I know that my first derivative is going to look something like this. And of course, this is going to be equidistant. So I'm going to find that equidistant point here. Okay. So what it's going to look like, it's going to look something like this. It's going to go all the way up like this. Okay. That is going to be my first derivative. Now, what we're going to have to do is we're going to have to look at the critical points, and the critical points, or the x points, are where either the derivative or the cubic function cuts the x-axis, okay? And so we're going to break this up into sections, okay? So section 1, how I'm going to do it, and I'm going to write it out here. So section 1, we know that this is going all the way to negative infinity. So section 1 is going to be from negative infinity to negative 2. Okay. Now, what I'm going to do is I'm going to write g of x here. And then I'm going to write g dashed of x here. And then I'm going to need a ruler. Now, what I'm going to do is I'm going to take this ruler and I'm going to look at the values of g of x and g dashed of x. Now, if you look at g of x, you can notice that my y value is negative. So that's a negative. Now, if you notice my first derivative, the y value is positive. And so the result of this will be a negative times a positive will give me a negative. Okay? That's my first area of interest. The next area of interest, let's call this number 2, is going to be between -2 and 0. And if I move my ruler there, what I then notice is that I can see that my cubic is positive and my derivative or first derivative is positive. So that's a positive times a positive, which then gives me a positive. We then continue past 0, and our next area of interest is going to be between 0 and 3. And let's call that section number 3. That's going to be 0 and 3. And now if I move my ruler past 0, what I notice is then I can see that I now have a positive cubic but a negative derivative. So I have a positive cubic and a negative derivative. Okay, and I know that a positive times a negative will then give me a negative. That's my next area of interest. Then I'm going to go to the next area of interest, which is going to be between 3 and 14 over 3. And that's going to be my next region. I'm going to write that in red. So it's going to be from 3 to, it's going to be from, just going to write it here, 14 over 3 all the way to 6. Right? So from 14 over 3 to 6, what do I have if I move the ruler? Okay. 14 over 3 to 6. Well, then I have a positive times a positive. Okay. You can see it there. Positive. Sorry, I have a positive times a negative. Okay, so that's the derivative is positive, but the cubic is negative, so that's a negative times a positive. And we know that will give me a negative. And then the last region is going to be from 6 all the way to infinity. Okay, 6 all the way to infinity. And here I have a positive-positive combination. which gives me a positive. Now, when I wanted less than 0, which are the combinations that gave me that? Let's move the ruler out of the way. And let's circle in green the combinations. Well, we know this one gave me a negative. We know this one gave me a negative. And we know this one gave me a negative. And of course you can see they say it here. Here's the answer. This I can write as x is less than 2. I know it's between 0 and 3. Now why do I exclude? Because they want less than and not less than equal to. And then I know it's between 14 over 3 and x is equal to and x is 6. Okay, so that's a very common question. And this is how we would determine this question here. Now, there's another way they could have asked this. They could have asked us like this. They could have said, where is g dashed of x all over, or g of x all over g dashed of x less than 0. Now remember, in this case, it's still, you're going to look for a positive over a negative combination or a negative over a positive combination because it's a fraction. Okay, I just want to open it up for questions. Okay, I'm just going to ask any questions. Any comments? Are we all good? Okay, please feel free to contribute in the chat. That just gives me a sense of how we're doing. Okay, and we're going to move on from this question. Okay, what I'm going to do is I'm going to, well, this is related to a sketch question. You can see it's from IB 2014. Okay, and let's do a little bit of analysis. Okay, so they say given f of x is equal to ax cubed plus bx squared plus cx. So we know that this is a cubic function, but what else do we know? Well, we can see that there is no d value, so we know that it's gonna, the y-intercept goes through the origin because there's no d value. Now, the other important information is this. F dashed at minus 1.5 is equal to f dashed at 5 is equal to 0. Now, what does the derivative tell us? It tells us the gradient. And where is the gradient equal to 0? Well, at the turning points. So this gives us a little bit of a clue about the turning points. And then lastly, they tell us that it's increasing between 1.5 and 5. Now, if you think about it, we have only two possible combinations. We have this, and we have this. And in this case, hopefully you've already figured out that this is going to be x is 1.5, and that's 5. Or this is going to be 1.5, and that's going to be 5. Now what I'm going to do is I'm going to give you 3 minutes to draw a rough sketch. And, well, then once you have the sketch, we will go through the next parts of the question. So I'm going to give you 3 minutes. See if you can draw the sketch, and then we'll begin to answer it. Okay, here we go. All right, so if we think about it, what we should know is that this is actually a decreasing function, right? It's a decreasing function because it's increasing between 1.5 or minus 1.5 and 5, which means that it looks something like this. So it's going to go down, turn up. Now we know that this is going to be some value minus 1.5, and y, let's say y1, it's going to increase, and then turn around and go down. And this is going to be some value 5 and y2, right? So we know it looks like this. Okay, and if you look at it, right, so you can see here's the turning point, but also, right, what would have been important would have been to draw that this goes through the origin. Okay, so the y-intercept goes through the origin. That would have also been key, and you can see that's what we have here. Okay, that's how we would have drawn this. And so now they want you to find the values of x for which f dashed of x is less than 0. Now if you think about it, if we're working with f dashed of x, we need to work out, or we need to draw the first derivative, okay, and work from there. And then concavity, where is it concave? Upwards. Well, remember, concavity is related to the second derivative. So this is a 2-mark and 3-mark question. What I'm going to do is I'm going to give you another 3 minutes, and then we will discuss and go.
Want to listen ad-free, download music offline, and keep songs playing in the background? Get YouTube Music Premium.
Okay, so let's go through this one. Okay, so remember we're going to have to draw the parabola in this case. Now remember the parabola is going to be related to the turning points. We know this is going to be a sad face parabola. Okay, now if you think about it, where is the derivative or the parabola less than 0? Well, it's less than 0 anywhere this way or anywhere that way. Now this corresponds to x less than minus 1.5, and this corresponds to x greater than 5, and that is going to be your answer. Okay, x less than 1.5, x greater than 5. And then the last one is, where is f concave upwards? Now remember, in terms of concavity, we then need to look at the second derivative. But remember, the second derivative is also related to the turning point of the first derivative, right? And that's halfway. So we know that this is going to be some line that looks like this. Okay, that's my second derivative, f double dashed. Now, can we work out this midpoint? Yes, we can. We just take minus 1.5, add it to 5, and divide by 2. Okay, and I get 1,75. Now, in this case, if they are wanting the concavity upwards, right, we know that this value here is going to be 1,75, and then the concavity upwards is going to be related to, I'm just going to highlight this in blue once again. This is the concavity upwards, so then your answer has to be, for this one, x must be less than 1,75. Okay, so that's that. Okay, so this has been a 45-minute jam. I think we can leave it at this. For those of you who attended, I'd like to thank you. So next week's jam, we will look to make it longer, maybe 90 minutes to 2 hours, just depending on how many join. But these are the 2 questions that I will leave you with. If you would like to register or sign up for any of our workshops, our exam intensive workshops, please reach out to myself. You can get the details off the YouTube channel, or you can contact me directly. But other than that, I'm going to leave you with that. And I wish you all the best. Hope to see you next week. Take care and chat soon.